All right, we're looking at transforming logarithmic functions. We've been given this question below, and this is our parent function here. It's our variable a does vertical stretches and compressions and flips. Our k value does horizontal stretches, compressions, and flips. D will move our function left and right, and C will move our function up and down. So with that information and this mapping notation, we're going to try to solve this question number 8. So we'll read it quickly, and we'll try to highlight what's important. The function f at x is equal to log base 10x has the point of 10, 1. Okay, so this point is probably something they're going to ask us about. If the function is vertically stretched by a factor of 3, okay, so let's put that together. Vertically stretched, factor of 3. Reflected on the x-axis. We'll try to do a different color for each one. Horizontally stretched by a factor of 2. And horizontally translated 5 units to the right. And I'm running out of colors here. Let's see, here's an orange. And vertically translated 2 units up. We got a whole bunch of information here. The very first question is asking us to build the equation with these translations in mind. Okay. Oh, that's kind of slow. Okay, so we have our function. Which of these probably deals with our a factor here, or a variable? Which of these instructions in the question do you think deals with it? Yeah. Yeah, so our factor of 3, it's a vertical stretch, right? So a vertical stretch by a factor of 3, that means we have a value that's greater than 1. So we're probably looking at an a value that is the number 3, okay? The next part about it, and we're not going to write base 10 because it's assumed if nothing's there. The next value would be our k value. What do we think the k value would be in this question? Yes? 1/2? Ah, good. And why did you say 1/2 for the k value? That's right. A stretch is almost the opposite idea in terms of it being greater than 1. If it's a horizontal stretch, that means we're kind of dividing by a value of 2. So we can just multiply it by 1/2 in that case. Then we have our x. What about our d value here? Anyone know? What do you think the d value is? Yes? -5. Why -5 when it says to the right? You're right. It is -5. Can anyone help them out why we write in -5 for that value? Anyone remember the rule? Yeah.
It's supposed to be minus anyways, and the number is 5.
Yeah, so the number is actually 5, and because the function already has a negative sign in, we're putting in, essentially think of it like we have +5 when we write it in, and when we have these two operations beside each other, essentially they can be written as just a negative sign. So that's 100% right. We're just going to write it as -5 to simplify it. Oops, I forgot I drew over that. Let's put negative. There we go. And finally, what about our c value here? Which one deals with our c value? There's only one left, I think. Yes.
+2?
Yeah, +2, right? It's going up 2 units. Did I miss anything? Yes, what did I miss? Reflection on the x-axis. So which value does that affect? Which value does a flip on the x-axis affect? A value. So what do I have to do with the a value? Right, as a negative. So this should be our equation for our a, and maybe we can test it out. -3, so a value is -3, k is 1/2, so we'll plug them in here. A is going to be 3, our k value is going to be 1/2. Whoops, that's not 1/2. There we go. Our d value is technically +5, so write it as a +5, but when it goes in the equation it would be a negative. Our c value is 2, and the a should be a negative, right? So we're looking at a function that looks like this, and the original function was just log x. Okay, so this is what our translation has done to it. It's flipped it on the x-axis, and they had a major point they wanted us to talk about. It was 10, 1. So let's see if we can't get that. 10, 1 was a point here. Okay. They also want us to talk about where this point would end up after we've translated this function. So we can use our mapping notation to figure out where exactly that point would be. Okay, so we're going to plug it in. Now that we know our k, a values, that means our x value here was originally 10. So we're going to have 10 divided by, and what are we dividing by here? Are we dividing by 1/2 or are we dividing by 2? 2. We're going to divide by 2. Okay, though we wrote it in like a half here, we are dividing by 2 here. So we're going to divide by 2, and we're going to add the d value, which was technically our 5. Okay, and then our a value was -3. The y from before was the number 1, since we multiplied by 1, and the c value was 2. So when we put this in, we're going to end up with 5 and 5, and -3 and 2. So we should have 10 and, -1. So according to this, we should have 10 and -1, assuming we put it into mapping notation. And then the domain and range. Let's go take a look at our new function here. So the red one is our new function. What is the range of this function? Who wants to take a guess? Yes, it is. This is a number that essentially, or sorry, it's a function that will go up and down forever. Though it really doesn't look like it here, it's definitely going all the way up and down forever. How about our domain? Yes.
XER when x is greater than 5.
That's right. We have a vertical asymptote at the number 5 with this function. Okay. So our domain and range. I think our computer's going slow. There we go. The domain. And it depends how your teacher wants you to write it. Do you guys use this usually? Yeah. Such that x is greater than 5? Would we write greater than and equal to 5? Why not? It never touches 5, right? If it's an asymptote, it never actually touches that value. And then our range is just y is every real number. Whoops, we don't need a such that. Okay?